So in order to do this, as before, I'll be using the 12 volt power supply instead of 240 volts AC. Okay, I've just removed the 12 volt cigarette lighter cord from the clamshell, and I'll be connecting it to this charger unit shortly. And by the way, if you haven't already figured out, this is actually quite light because obviously it has no transformer block in it. Okay, so first things first, let's insert this into the cigarette lighter receptacle on the battery. Right then, so as you would expect, this unit takes between DC 11 and 16 volts, just like it says on the sticker behind it. So I'm going to hook this up. And as you would expect, these cords are quite thick and of good quality because don't forget they're carrying 4 amps of current at 16 volts, well 12 volts from this battery, but that's still very significant. Okay, so the way this charger works is the LED will light up either green or red. Red means it's charging, green means it's completed, it's charging. It's obviously got independent charging capabilities, so it will monitor the voltage and temperature of each slot, and charging to the respective slots will end when the respective batteries are fully charged, obviously. So what I've got here is a Sanyo Eneloop that's about 60 or maybe 70% charge. I actually charged this up with the Nightcore DC charger until the point I couldn't wait anymore. So yeah, once again that was a universal charger, whereas this is very specific. It only works for nickel metal hydride cells. It is too powerful to charge 9 cat cells, so don't try that because you're just asking for trouble and the cells will degrade with all that current going to them. So I'm going to go ahead and insert this Sanyo Eneloop battery into this charger. Now this battery was previously charged up to about 65 to 70% using the Nightcore DC charger D2, but I had to stop the charging sequence because I had to leave my house, so it was left at that state. So I'm going to insert this. Now the spring tension on the positive terminals here is quite strong, so I'm going to use 2 hands to install the battery. So there we have it. The battery has now been installed and the light turns red. You can probably hear the fan spinning up. Now the fan will speed up as the charging progresses. Once the battery is fully charged, the light will turn green as you would expect. And if you haven't already figured out, there's one drawback to this charger in that it will only turn green once all 4 batteries are fully charged. So say you had 2 or 3 in them of varying charge levels, you wouldn't know when the one that's fully charged is fully charged until all of them are fully charged, if that makes sense. While that's being charged, of course the cell heats up very quickly because of the high current going through it. It's already getting warm. It is already warm actually. So just want to warn you, you might be tempted to use this to charge a cell that doesn't fit in the slot, such as a prism shaped NiMH cell or sub C or D size cell. Technically you could do that by wiring them up to the terminals and having them set externally, but I would strongly discourage that, because once again, high speed chargers like this need to be able to monitor the cell's temperature to determine when they are fully charged. So that there will run for around 5 minutes, I would have thought, after which the light will turn green and charging will stop. Okay, that's it for this. So this is a very specific single purpose charger that's made for speed charging nickel metal hydride cells of AA or AAA sizes, and that's all it does. But okay, now we can remove it. The fan is spinning very fast, as you can hear. Now this battery is actually quite warm. There you go, the fan has just turned off.